70% attendance during our talks. Now, in this room, we're going to have a panel on visions and versions. We'd like to invite to join us Dornelles Freire, who will be the moderator for this panel, and José Vitor Bomtempo, a professor at the Chemical Engineering School in the Federal University of Rio de Janeiro, who is attending from Canada. Leonardo Simon, a professor at the University of Waterloo, who is joining us from Canada, and Professor Marco Aurelio De Paoli, a professor from Unicamp and the current head of ABPol, the Brazilian Polymers Association. Welcome, gentlemen. Welcome to our panelists and our moderator. And we will immediately pass on the word to Mr. João Dornelles Freire. Welcome, João Freire. Over to you so you can begin this panel. Welcome. Good afternoon, everyone. Good afternoon, Luis Afonso. I'm just getting organized here so we can begin. It's a pleasure to be here supporting this conference during this panel. This is a panel which, in my opinion, is going to provide a very interesting view on a little bit of everything that has already been said today. As panelists, we had professors and PhDs. We had members from academia who run studies and generate content, such as Professor Marco Aurelio Paoli, Professor José Vitor Bomtempo, PhD, Professor Leonardo Simon, PhD. I believe they're going to give us a brief understanding and will give their perspective on what we've heard today. From the first talk from Thais, who gave us a broad view, who was also very objective, providing new paths for the circular economy. Then we talked about the cooperation network and the initiatives that we received in companies and union entities. We just heard from Gerson Haas from SustenPlást. So right now, this panel is going to give us a perspective on each one of these researchers and what their perspective is on all that we discussed. For this panel, we're going to receive 3 questions, and each of the questions will be answered by each panelist. They're going to give their perspective, and then at the end of this first moment, in which we're hearing their perspectives, we're also going to get their versions, right? Because nothing is so exact to the point that it only has one version. So our commitment in the Brazilian Plastic Congress is to give you content so that we have more convergent and productive visions and versions. At the end, we're going to have some time for debates. So, first, we're going to be talking about what the organization itself proposed. So the first thing we want to talk to our panelists about is the applications of plastic. This broad experience that was discussed during all of our panels, we'd like to hear from you. What are the highlights in plastic applications in healthcare, in food preservation, in consumer goods? So let's talk a bit about the applications. Our first guest will be Professor Marco Aurelio De Paoli. He has a very long CV, which I mentioned, but I'll read here. He has his PhD in the Federal University of Brasilia and in the Chemical School of São Paulo. He also studied in the Max Planck Institute and Frankfurt University. In '77, he worked as a professor and researcher in several internationally renowned institutions. He published hundreds of studies on this area. He was also a counselor for several dissertations. He's worked in polymers and electrochemical areas, specifically on degradation, polymer stabilization, thermoplastic formulation, conductive polymers, and other very specific topics, which are very relevant for today's discussion. So now, let's hear his view of the applications of plastics. Professor Marco Aurelio De Paoli, PhD.
Macon, Professor. Sorry, I'm so sorry. Well, first of all, I'd like to thank you for the presentation. Thank you for the invitation to participate in this debate. As president of the Brazilian Association of Polymers, I think it's always important to discuss these issues. And within these topics, I understand that we're going to talk about 3 subjects. First of all, we're going to talk about applications, health applications, consumer goods. Currently, it's difficult for you to talk about plastic applications. It would be easier perhaps to talk about where it isn't applied, because you also wouldn't find anywhere. In the health area, if we today walk into a surgery room, we're going to find more plastic materials than we would find 20 years ago. All the equipment is made of plastic, the hoses, the syringes, a lot of the equipment that the doctors use, and even the surgeries that are done remotely when the doctor works on the computer that he's using is made of thermoplastic, so is the mouse. So really, the probe he uses, the health area today would go back at least 150 years if we did not use the thermoplastic products. So they are extremely important. In the health area, it's not that known, but a few years ago, there was an additive that was launched for food greenhouses that optimizes the wavelength where the plant does its photosynthesis. So with this additive and the plastic cover, you're able to increase the productivity of a greenhouse plantation about up to 30%. So imagine how important this is in terms of productivity. The same area, the same system, the same greenhouse. The only thing that changes is the formulation of the plastic, and then you can increase this productivity in 30%. It is amazing. And what about consumer goods? It is an area that, I tell you, it's impressive. Everything that we use nowadays, let's talk about what we're using more frequently in this phase of video conference phase, which is the computers that are totally made with injected thermoplastics. All the electronic circuits are made also by thermoplastics. Therefore, this area of consumer goods is the area that most benefits with the usage of these products. I believe that if these were eliminated, we would go back at least 2 centuries in consumer goods that we have available. So it's very important, the usage of these materials. I'm not including the elastomers that are also polymers and also participate in all these sectors. So these areas were chosen: health, food, consumer goods. These areas today depend strongly on the thermoplastic materials. This would be my main contribution right now. Thank you, Professor De Paoli. Well, now I would like to listen to the vision of Professor Vitor Bomtempo, the mentioned applications, and bringing to this vision of the professor those applications that are in our day-to-day lives, that we of the industry, we have some theoretical base, but the normal citizen, he still has a lot to learn about the possibilities of these materials. So please, Professor Pedro, the floor is yours. Good afternoon. Good afternoon, everyone. It's a pleasure to be here with the colleagues, some of the colleagues that I'm getting to know now, De Paoli, Leonardo, and especially the event, because I am absolutely amazed, blown over by this event. I watched it the whole morning, and now I have a lot of responsibility to add comments and give additional insights compared to everything that was already discussed today. I am going to explore a side. I think my profile is a bit different to De Paoli and Leonardo, even though I'm an engineer by profession. Well, there's no chemical engineering complain, but you study chemical engineering at the chemical college, but I'm a chemical engineer, dedicated his life to forget chemical engineers. I still dialogue with a few of them, like De Paoli, Leonardo, and Freire, but I went towards the innovation economy and the management of this economy. That's how my research groups works in this circular economy. So we have a background way back when I was 40 years old of chemical engineering, but the work we do has everything to do with the strategies, with the innovation processes. So I'm going to try to complement what De Paoli said, remembering that we've all been more or less at home for 1.5 years. And at this time, we dealt with plastic the whole time. Plastic in our face masks, plastics when we started to having to clean food, separated, that increased my consumption of plastic film. And then we went to take our vaccines. We had contact with this syringe. And in this process, we notice the participation of this material. But the interesting side is, what does it ends up by being the basis of some interesting innovations. Another thing that we did frequently, everyone cooped up at home, was to ask for delivery for food. Restaurant, I can't even remember what a restaurant is. It seems to be a place where you sit down and eat, but like everyone, we phone our preferred restaurants, and then you have the famous packaging, that little plate where the food comes. So what do I do with this? Well, you trash it. But then there's an opportunity, an interesting opportunity, and that's where the circular discussion of economy, the applications for plastic, everything is always linked to movements of new business, finding new intelligent ways of dealing with material and with the then a company from Paris shows up, and their scheme is they manufacture equipment, they manufacture pots to the restaurant sells the food, they give the pot back, they go to the restaurant, they collect the pots, they have washing and industrial washing process, they clean the pots and give them back. So it's a renewal of a business model which is took place because of the pandemic, and it's quite interesting. I think this relationship between the potential, the technical potential, specific technical potential that De Paoli brought us, this is something that incentivizes new business models, new efforts. And then when we think of another application, I think, for example, I think everyone increased their wine consumption. And the other day I read something really cool in the Financial Times. It's not a chemical magazine. It's a newspaper. It's a very respected business economical newspaper. And the article said, what is the most sustainable packaging for wine? Everyone believes it's glass. And this article showed how glass is a problem. It's heavy. Each wine comes in a different glass. How does this? And then they showed the alternatives. And there's someone using PET, another one with using cans. That's rather a shock, right? Imagine the next delivery, we're going to receive a can of wine, 300 mLs. But that is a interesting discussion, and I thought that this was very well inserted into this pandemic time. So I think the plastic has a very important role in applications. It has its role in the pandemic, will continue having its role. And I wanted to remind you that there's the technological side and there are the business model innovations, which is very important as well. Thank you very much. Thank you, Professor. And I'm going to correct something. I did not read your introduction, so I'm going to do this now. I'm going to read your CB Chemical Engineer, Federal University of Rio de Janeiro, Master's Production Engineer copy, also in the Federal University of Rio de Janeiro, of the School of Mines in Paris, coordinator of bioeconomy studies. And then this experience that you presented us, when you talk about the solution, the usage of plastic in the economy, and the best applications of plastic in your utilization. Thank you so much, Professor José, Vitor, Bomtempo. And now we give the floor to reading these applications, Professor Leonardo Simon, who is a professor of the Waterloo University Chemical Department ever since 1982. He's been teaching in the graduation program of the polymers engineers here in this university, and he has experience also in the Federal University of Rio Grande do Sul, where he researched characterizations of materials and nano compounds. Professor Simon, your vision of the applications of plastic. Thank you, João Freire. I hope that you can hear me, just so that I confirm everything is on. Is my mic on? Okay, yeah, perfect. Well, I'd like to start thanking Alfredo Schmitt for the leadership and the execution of this Congress, all the team that is participating, the sponsors who are extremely important. Thank you so much. The panelists, Professor De Paoli, Professor Bomtempo, I agree with what you said. I also have participated and I enjoyed the conference this morning. I think I will get the certification. I think I'll continue watching. I'm just concerned with this 70% because I only watched one of the lectures. I'm going to get to 50% by the end of the day, I believe. But I'm going to spend the day connected. Well, this morning, one of the talks that most inspired me was that talk offered by Fabiana Quiroga. This talk showed that the company or the Brazilian sector is committed to continue in the leadership of sustainable innovation. So now I'm going to put this lecture that Fabiana gave and that inspired me a lot. I thought it was very interesting with the topic of our debate, which is what is my vision of plastics in health, in food and in our routine day-to-day life. I am going to focus on health, especially the relationship with the pandemic and my experience, my response specific to the industry, especially here in Canada, but I also had to interact with other companies, the suppliers of raw materials, of resin, especially polypropylene in other countries, because local manufacturers had to involve masks. It's an imposition of the federal government and the provinces of Ontario, so it was necessary to use masks. So there was a development of this local production of masks, and then the problem of finding the raw material. The raw material to make the masks is not plastic, it's polypropylene. I'm referring to that. Here we have a large market, and there are few companies that only have two ways to go. And it's plastic that has a specific feature so that the mask reaches the norms to fight against illnesses. Now let's move into the technology. The masks that are made of non-fabric, they have a sort of a mesh which is much thinner than a strand of hair. And this generates the porosity that will stop the air that we breathe. So there was a quick response of these supplying industries and the communication with the production of the masks so that this distribution and production could happen. I think this is very interesting. It shows that the plastic industry is ready to respond to the needs of society. Now, one thing that I like a lot, which is a story of the consumer industry, I will mention the topic of the circular economy in the agribusiness, the relationship of the circular economy with the agribusiness and the food industry. It can be fuel and it can be food. In this context, in this pandemic context, the importance of the ready-made meals and delivery meals increased it, as Dr. Bomtempo said, the new business needs. And in terms of technology, there is a food which I love using as an example, which is frozen food that the person purchases, takes home, puts in the microwave, and eats it in the packaging that it comes in. This packaging of food tends to be the villain of the story because it's a packaging that it's contaminated with fat. I like to use the example of the frozen lasagna. I think this is good food to freeze, to defreeze, and eat in the packaging itself, and it is a villain. And at some points, what there is lack of technology, and the people that end up by crucifying the packaging don't realize the benefits of the preservation of the food. So now I'm going to stop with my contribution, and we can go to the next question. We can move to the next question. Thank you. Excellent. Your contributions are wonderful. Now, me as a chemical engineer, 40 years working in the segment of polymers, I did not have this specificity about TNT, about the fabric of the mask. There's technology inserted there, embedded there, and very few people read it this way. But that's exactly what the goal of a Congress. You talked about different applications, different usages, being benefits for people, for life, for the planet. Now, it's also been mentioned a lot, the question of the circular economy. We can't run away from this topic, recycling and correct disposal. So I'm going to ask you, gentlemen, now I'm going to try to ask, I'm going to start with you, Professor Leonardo, asking what is the technology reading to contribute in the recycling, the circular economy, bringing this return with the value of these materials that have so many different applications for the life of people. So Professor Leonardo, let's start with you. Thank you, João Freire. Well, now I'm going to be a bit more critical. My critical vision to us as actors in this plastic industry and members of society, what is circular economy? Why do we need circular economy? When we ask this question, we have to be very careful not to make circular economy a problem of solid waste. Many of the comments and statements that I heard from the speakers this morning, on the point of view of engineering, this is very similar to management, solid waste management. I'm going to use an example, a concrete example here of the plastic bags. Plastic bags are a problem when they go to the wrong place. And plastic bags, they don't have legs, as Professor Bomtempo said. They don't walk to the sea, and they don't go into the turtle's mouth by chance. Someone threw that plastic bag in the sea. Now, if you look at Japan, do they have that problem like cities like Tokyo? No. In Japan, the plastic bags, like any other plastic material, goes into a program of energy recovery. It's incinerated. So this is a solution that works for Japan, and they don't have this problem.
This problem cannot be generalized. It needs to be analyzed geographically. The Japanese solution is not the same solution that's going to work in the Brazilian or European market. Some European countries have a policy, an economic or social policy, to encourage recycling. Other countries prefer plastic composting. So it really varies depending on the geography and education. Now, why aren't plastic bags a problem in Japan? Because no one litters, and if anyone does, by accident, there is going to be someone who's going to collect that litter. Where I live in Canada, it's the same. You don't see any litter on the street. When you do see it, I try to collect it from my own street. So this problem with litter is not about plastic, but rather about education. And where does the problem arise? It comes from our lack of education and training, both at the individual level, as Fabiana said. She mentioned it as a professional and also as a parent. My daughter sees this and I don't know how to respond. She sees people littering and I don't know how to respond. So how do we educate our society? One of the answers is a program like Tampinha Legal. This is a program that's not going to solve the issue of plastic waste, but it's going to teach society, especially young people, how they can solve the issue. And in the future, all individuals will behave like the Japanese, which do not litter. Second role of education is the interaction between universities and companies. It is the role of companies that process plastics to talk to universities, especially at the undergraduate level, and to provide them with internships so that engineers or future mechanical engineers, chemical engineers, managers can understand what are the challenges in the company and bring this to an undergraduate level. When my students ask if they have to go to a grad school, I often say that in the undergraduate world, you're going to learn to solve issues that we already know how to solve. There are solution manuals for problems in textbooks. But when you go to the postgraduate level, that's when you start solving issues or understanding issues that have not been resolved yet. So circular economy today is a graduate level problem. It needs to be understood. It needs to be put into context. We're dealing with materials that are 100 years old. Plastics are 100 years old. Thermoplastics, as we normally use them, polypropylene that is injected and extruded, is not a natural material. It's man-made, it's synthetic. So just as we learn how to use it from the technological point of view, we also will need to learn to use it in the context of a circular economy. Thank you. Thank you, Professor. So I'm now going to invite Professor José Vitor Bomtempo, who also has worked in public policies and strategies to develop this area. Right, Professor João Vítor? That's right. Thank you, Freire. So to continue Leonardo's reflection, he developed the cultural differences in education that make the circular economy something that is, well, basically local or regional. That's an important dimension that should not be forgotten. Solutions are going to be different. Oh, but there's an important correction here. You've talked about plastics not having legs or wings, and that was a quote by Schmitt. So let's not forget it, otherwise we will never be invited back to the next events. After all, this is one of his phrases, and you can't change the author. So again, this was a quote by Alfredo Schmitt. So Leonardo mentioned the cultural side of littering. I lived in Canada for a year, so I know what that's like, right? The Canadian way of being, the American way of being, and the Japanese are a great example. But we, of course, have our own cultural specificities. In circular economy, we have a discipline which is a reflection of how to structure the circular economy. One thing we perceive is that there are technology dimensions that need to advance. Leonardo mentioned the lasagna wrapper. So there are some technology challenges, but there are other challenges related to innovations that are not connected to technology. I'll insist on a similar point. When I think about the reverse chain, reverse logistics, as we call it, it goes beyond that. In circular economy, I have a group of things that I didn't deal with directly, which I wasn't involved in. So there's a very challenging range of problems. I've noticed this during the presentations, when Brest came and others had their presentations in the morning. This is a very important challenge. And when you're in the realm of technology, some years ago, we had a study on chemical recycling. This was about 7 to 8 years ago. What we found is that technologies existed, but no one knew how to structure a business around them, because you had plastic shavings that were to be recycled, but this was unstable, and the product was also unstable. Now, this is different. Braskem is compliant with the idea of chemical recycling. And when I think about chemical recycling, it's more directed towards waste that could not receive value otherwise. So that the advantage was that we could go back to virgin resins, to naphtha. The technology still needed to be developed or optimized or grow. And at the same time, you have mechanical recycling. You have the redesigns that can modify or reduce the use of circular economy. So adjusting all of that is quite challenging. It's not a small problem. I liked seeing all of the proposals today. I think it shows maturity in how this is being reflected on, but I think there's still a problem. The technology needs to be developed, of course. And well, I see some companies in the petrochemical industry saying that they're going to include chemical recycling units in next to their crackers, but these are 20 to 30,000 units. So how much plastic shavings will be consumed? Is there enough space to have chemical recycling units in mid-sized cities so that it can be transported? Of course, this is just speculation, but what I'm saying is that we have a technology challenge and a structural challenge in how these businesses will be structured. So that's a very important challenge that we cannot forget. This discussion needs to be ongoing, and of course, we always need studies. This is something that has a very important regional aspect, of course. Thank you, Professor José Vitor. So now, coming back to the beginning, we'd now like to hear from Professor Marco Aurelio De Paoli and his considerations about this, the circular economy. In this positive applications topic, but let's hear from him, Professor Marco Aurelio. Thank you. I'm going to try to add to what has been said by the previous speakers. Said very well, by the way. Leonardo mentioned a very important point, and I would reverse this theme here. He says that it's important to dispose of things correctly in order to have circular economy. Everything depends on correct disposal. And as he said, this will all depend on education. I'll give you an example. About 20 years ago, all the chemical institutes and all the universities of the state of São Paulo implemented programs funded by FAPESP to manage chemical waste. So chemical institutes would receive the funds if they implemented a chemical waste program. So nothing else would be disposed of down the drain. All the research labs and all the educational labs had to implement these programs. So a chemistry student knew that at the end of his lab class, he would have to dispose of acids in the acid vat, organic waste in the organic vat, and so on. And by doing that, we created several generations of chemical engineers. All the students who went to labs in the chemical institutes in universities of São Paulo had to undergo this process. There was no other way around it. After an experiment, you had to dispose of chemicals in the right place. Otherwise, you would fail. That's all. So we created several generations of chemists who, from the first time they went into the lab, had to learn how to dispose chemical waste. I think in plastics, the same should apply. We need to create, for the next generations, the same mindset. Plastic cups need to be disposed of in the plastics waste bin, and so on and so forth. Just as Leonardo sorts his garbage, I live very close to a park And oftentimes I walk around the park and I bring a plastic bag, and I always come back with it full of plastic. And I throw it in my plastic bin because I know that recycling will come through later to collect it. So that's it. There is a lot of advanced technology for recycling. There are companies that make full plants. If I want to have a recycling company today, I can make a full plant from washing to pelleting. All I need to do is get funding, get a location, but the raw materials will come from people who disposed of it in the right place, recyclers who took it and who brought to them. So it's that issue of input. The raw material will depend on people, on education. I always say that throwing a PET bottle in nature provides three losses. First, you're disposing of a raw material. Secondly, you're damaging the environment. And then you're going to have to spend to recover that environment again. So littering really is triple the loss, right? So this is an important message I have for you. If you want to invest in the circular economy and recycling, you need to invest in education. You need to go from basic education. You need to have 3 trash cans for metals, plastics, and organics. And that's where education starts. I think that's a very important point that we really need to underscore. The example we had today with education in disposing of chemical waste was very important because it applies to the medium and long term. And every chemist is aware of the fact that you can't finish an experiment and just throw your waste down the drain. Thank you. So circular economy is something that we discussed very well, right? From education to culture to technology. So we really can see that there's a convergence, right? A convergence between all positions on how important it is to discuss it. But now I'd like to invite you to think about the future. What can we understand from the major guidelines or the major trends in the products used and their materials and the possibilities that they have? Moving out of the box, right? Moving out of our reality, trying to think about the future. Where will these possibilities take us? And we need to include here what solutions we can provide for all the issues we discussed. So let's start with Professor José Vitor Bomtempo, who might be able to help us think about the future. Thank you. I'd say that this isn't risky. I mean, it is risky, but don't tell us anything if we get it wrong. Maybe we can say that circular economy is a given today, right? The problem for the future, well, you know, the circular economy is well understood with all of the nuance that we mentioned here, but the problem for the future goes beyond having a circular economy, but rather removing carbon and being sustainable. You could have a very good circular economy without going in so deep into that, without being so successful in removing carbon. So you need to be carbon neutral, or even in some cases, carbon negative. We heard about that in the talks today. We talked about these 2 different stages. When I look at petrochemical companies, there's a study from the OECD on the future of petrochemicals. It states that the petrochemical industry will be the fastest growing industry for fossil fuels. Since the use of plastics will increase, we see that in developing countries this is natural. And since transportation will then change, the petrochemical industry will be the industry that most would be responsible for using oil. We recently saw that refineries had to be restructured considering a reduction of byproducts. And this converges into units that are starting to deal with renewable loads, with oils, fats, and greases. So this leads us to an area that we've been working on for a long time, which is valuing renewable resources and waste. So this is something unavoidable. When we think about plastics in the future, we need to think about bioplastics, which is a very complicated agenda. Bioplastics today represent 2% of the total market value. They have very high growth rates, right? They have a low share, but the growth rate is high. So that doesn't mean that it's so exciting. That some of these bioplastics are what we call drop-in. They're the bio-based version based on renewable resources for fossil fuels. For example, Braskem polyethylene. It's very similar to polyethylene made from naphtha or natural gas, but it's based from ethanol. So it's one kind of plastic. For the circular economy, for waste disposal, and for recycling, it's the same thing as a common household polyethylene developed, in 1940-some.
On the other hand, I have a bioplastic generation that are new. These are new polymers that are not part of these large and thermoplastics that we know. So these materials sometimes are biodegradable. Sometimes they're biodegradable under certain conditions. So they have an interference in the usage. They can bring into addressing functionalities. For example, there's been a wave of investments in the oldest type, but this material also brings a lot of difficulties with it. So when you say it's biodegradable, this can be interesting for certain applications, but on the other hand, if it's only biodegradable in industrial setting and not in a residential setting, this can complicate things. So all this agenda of the bioplastics, which is out of the domain of the traditional petrochemical companies. This is just an illustration that I'm going to give. For example, you have one company making a resin that can substitute PET, which is Coca-Cola and all these producers of drinks and mineral water, soft drinks, etc. If they want to change the fossil PET for something non-fossil, they have two routes. Either they make a renewable PET, the same as the fossil PET, but with renewable raw materials, with challenges. There are some companies trying to do that, or you change the resin. Then you make the PEF, which is the main candidate. But then you have to know how this is going to work in recycling. Perhaps it won't work so well. But you tend to have a variety of materials, and then you have materials that don't come from the imitation of PET. They can come from this paper and pulp industry. There's a Finnish company that's very interesting that's becoming a biomaterial product, bringing solutions, type plastic, films, packaging solutions. Every week you'll find something new. So they're not a petrochemical, they won't be, but they will participate in the future of plastic. So there's a very interesting, rich, varied future for the plastic and new challenges for whoever is playing this game. Well, thank you very much, Professor José Vitor. In the sequence, Professor Leonardo Simon and the future, what can we imagine as the guidelines of the plastic in the future? Thank you, João Freire. I'm now going to change my posture to an optimistic posture. I like being optimistic about the future. I would like to start agreeing with what De Paoli said and what with Professor Bomtempo said in relation to the circular economy, and bring and mention what they said a while ago for the circular economy in the future. What would be the circular economy and plastic in the future? I would like to share my vision in a few different compartments, a few dimensions, so to speak, so that we are able to think. There are plastic materials
utilizados em
that are
aplicações
used in durable applications. One of the examples I'd like to give is a tube for polyethylene in the building industry, which has dominated the market. Polyethylene pipes with a guarantee of over 50 years. This is a revolution. So, in the same dimension, I would put another level, the short-term materials, which are the packaging that we talk so much about, the straws and all these single use, all these materials that we use that have a short life. Another context, another dimension is the source of the raw material. Our raw material for plastics comes mainly from petrol, with the exception of cellulose, which is one of the oldest plastics that's come from cellulose. Ours comes from petrol. If we remove, or if we have the desire of removing petrol from this equation, the point of view of engineering calculus, well, let's remove this. What will be the influence of what will be the variables that we'll have if we remove this term? Our source of atoms today either is petrol or agribusiness. We have the example of paper and pulp industry, the industry of oils, industrial oils, chemical numbers affecting the plastics, foam of polyurethane, which is made of soy oil. So if we remove fuel from where raw material comes, we'll go to the agribusiness, one of the best examples in the world of biofuel, which is bioethanol. In Brazil, that's something that works very well. It has its structure, as Vitor Bomtempo mentioned. It has structure that favors this due to the geography. In Canada, bioethanol does not have the necessary productivity. So we go back to that geographic condition, the education. So we have the durables and those with the short life. Where does the raw material come from? From fuel or from agribusiness? Extending this dimension of where the raw material comes from, I like to think about the cycles of the atoms that we know or that we study. The cycle of nitrogen in the atmosphere, the cycle of hydrogen, carbon, and these are established by geological ages, millions and thousands of years, how it falls and how it goes back to the rivers and to the ocean. the cycle of the carbon or the CO2. When we talk about new materials, we have, if we have this idea of the circular economy, we have to think that now, in relation to plastic, we're dealing with materials that are molecular in their essence, different to metallic materials or other materials. These molecular links, they need technology that is not well known. So we have for a few hundreds of years ahead, because we're beginning this age of plastic. We have 100 years of plastic. So I want to give you two examples. I want to make a comment about the plastics that we know today. The solutions exist. I'm optimistic. The solutions exist if we're open to combine the essence of technology with the structure, which is this education of society. Then the majority of our problems will be solved with the products that we have today. What I think deeply about are the plastics that we're inventing now and that are going to come into the market in the next 15 to 30 years. These plastics that are going to be used in batteries for our mobility, we're already beginning to see this. And the Internet of Things, I have a son who's now going to high school, and I say to him, look, these screens that we see everywhere, they're screens. These screens, when I was small, I used to see the Jacksons cartoons because they used to use screens to communicate. It was a telephone that has a TV, and today this is a reality. These screens are going to become consumer materials the same way that we change our car or that we change clothes in the future. And this is going to be done with much more complex materials, atomically and molecularly, and which will require solutions for things that we still don't know. Thank you very much. Thank you, Professor Leonardo. Well, in sequence, we're going to finish with Professor Marco Aurelio Paoli with his vision of the future. What can we expect for all of this as a whole, the applications, the sources of raw material, and the solutions? So in reality, as our first speaker said, we have to think about the set of everything, the sustainability, the production, and the end. So, Professor Marco Aurelio Paoli, the floor is yours. Well, this issue of the future is very interesting because a lot of things that we see as totally innovative started to be in research 10 to 15 years ago. So, for example, the nano compounds started to be researched in the 80s of the last century. The first patent was in 1990. Applications of modern plastics, for example, the organic lead, that's a polymer. The plastics are polymers. So for this to work, you need another plastic, which is a plastic that conducts electricity. This is already produced in large scale already for 10 to 15 years. So that is what Leonardo said of the TV. Before that, there was Dick Tracy, and he had a TV on his wristwatch. So that was the sort of, you saw that in the newspaper. I used to see that. And I saw this in a congress in San Diego. I think it was in 2001 or 2002. So all these are old things, right? The organic lead is already old. So the photovoltaic plastic cells, flexible cells, already were in the market 15 years ago. So all of this is old. But if we think about the future, what I see for the future is that thermoplastics is a product of the chemical industry. They need raw material, and raw material today is petrol. On the other hand, if we look to the two polymers that are most found on our planet, cellulose and lignin, these are, any plant has these two components. The grass, a tree, a small plant, the structure can change a bit. The structure of lignin can change as well, but what we hope for the future for the plastic industry to have are the biorefineries. So what our future is going to reserve for perhaps 20 or 30 years in the future are the biorefineries. There are a lot of groups of research working on this. For example, the cracking of lignin. You can do that the same way as you do it with petrol. So you have to develop the adequate catalyzers, the adequate process, but this wasn't done with petrol from one day to another. It took many decades to develop the processes and the adequate catalyzers. And it's going to take some time as well to develop catalyzers and adequate systems, for example, to crack lignin, produce raw materials for us to reach the phase of plastic. So what I see, if we think of plastic in the future will be generated from raw materials, from renewable sources like lignin and biorefineries that are going to generate the raw materials, whether they be for any application. And I'm going to mention here, for example, another new old one. If you take a Boeing airplane, there are no more curtains. You have a button that you press, then it darkens, or it goes up or down, it becomes light or dark. I don't know if you've gone on one of these new ones. Sorry, they don't go up or down. They get light or dark. It's everything plastic. It's all polymer material. This started being researched, I don't know, 20, 25 years ago. So if we wait, or if we survive a few more decades, we will see refineries that are oil-based, and they will be bio-based refineries. And with this, perhaps we will be able to save the human race. The planet will survive. In 200 million years, this planet will be here circling around the sun. What I want to know is if the human race is going to survive. That's what we have to take care of. So within this message of the future, I think the biorefineries are the future. They're going to generate bio-based raw materials to produce plastics to attend to the needs of the market. Thank you. Thank you to all the colleagues who contributed a lot.
Seu microfone está
Ele está com o microfone desligado.
Your mic is off. Well, he's very stubborn. He's saying the polymer is not very good. I open it and it does something alone. Well, thank you very much for your reading of the future. And I think that the diversity presented here has reached the goal that we had in our minds when we asked you to talk about this vision, when we talk about the applications, the quality, applications focused on the circular economy and the future. Complementary positions, configuring what is already clear. It's not just one solution that is going to bring the convergence of the solution to these issues. I have here professors, I have some readings, and I have a question from our Congress, our listeners. The first question is from our friend Julio André, who is from the union, plastic union, and he says that there were a few years ago, there was a campaign when we used to say, plastic doesn't have wings, can't swim, and doesn't have legs. And the adequate disposal is the solution. So that is already what the Union of Plastics in Rio Grande do Sul, they are bringing their contributions towards this discussion. The question that is a more objective question about plastic bags, I agree with their importance, but there's a lack of education. Once more, this cultural and education issue, we have to evolve to biodegradables, and also the issue of biodegradability. Now, if you'd like to say anything more about biodegradables, we've already talked about it, but please feel free to add any comments. Well, I would like to make an observation. It's not enough to be biodegradable. First of all, you have to analyze the cycle of life to find out if that material really benefits the environment. And in the second place, biodegradable is a material that decomposes in CO2 and water in a decomposting plant. So if this plant does not exist, this is not going to solve the problem to use biodegradables. Thank you very much for your contribution. And now we have another question from Augusto Morita. He talks about prices. These materials, these biodegradable materials, were they were developed in the petrol crisis. There was space in the market, obviously bringing some development. But there is this issue: how do you treat this logistic? How do you do the process? I have a comment here. One of our participants says, "What about the more complex plastics?" Degradation, polyurethane, epoxy, elastomers. What is your vision? He mentions epoxy, elastomers, and more complex plastics to recycle. It's José Eduardo Salgueiro Lima asking.
Outros panelistas permitirem, eu vou começar a responder essa aí.
If the other panelists will allow me, I'll answer this one. This is a difficult question. Let's say that we have thermoplastics and thermofixed products. Thermofixed products are very difficult to recycle from the technology point of view. It's very similar to recycling ceramics. Ceramics need extremely high temperatures to be reprocessed. One challenge I'm more exposed to is recycling carbon fibers. This would be, of course, close to the plastic industries, but carbon fibers make plastics have much more weight and mechanical resistance, but it also requires much higher temperatures to be recycled. All of these resins have this issue. And we need to look at those from the point of view of circular economy. If the energy required to recycle something is too high, should we stop using it? I believe that in some applications we can improve it. There are many applications. I work in research projects in the auto industry. My university is close to Detroit, and there's a big concern for the automotive industry not to send anything to landfills. This is their directive, not to do anything in landfills. So when a car is made, some parts might have flaws, or they might, for example, go through processes that leave behind tailings and shavings. which need to be addressed. All ceramic materials, all thermal fixed materials generate issues. So this is an unanswered question. Thank you very much, Professor. Can I add something quickly? Polyurethanes can be recycled chemically. There are chemical recycling processes for polyurethanes. That's just my note. Okay, thank you, gentlemen. Professor Paoli, Professor Vitor Bomtempo, Professor Leonardo Simon. The organizers, thank you once again for being here and participating in the 4th Brazilian Plastic Congress. You really made very relevant contributions to our discussion. So we'd like to reiterate our thanks. Thank you so much. We've run out of time, so thank you everyone for being here once again, and have a good afternoon. Thank you. Thank you. Good afternoon. And I hope you'll stick around. We have more talks ahead of us.